class 12 physics chapter current electricity, we are going to deduce your expression for drift velocity. For this, what should be known to you? Simple result that if suppose this is a conductor and no electric field is set or no electric field is present, what about the free electrons inside the conductor? So in that case, the free electrons have thermal velocity. The first electron suppose having thermal velocity u1, second is your u2, and so on. Another electron having thermal velocity suppose un, but the average thermal velocity is always 0. So this is known to us. Now the situation becomes different when the conductor is connected with a battery. So this terminal is connected with a battery, positive terminal, and this terminal is connected with a negative terminal. This is a conductor. Magnifying the conductor, we are observing this. Now see this. Whenever the two terminals of the conductor connected to the two terminals of a battery, then what happens? Electric field is set in the conductor from positive to negative terminal. In that case, the electrons experiences a force towards the positive terminal. Each and every electron, free electron, experience a force. Then what happens? The electron, first of all, say let me consider the first electron. It will start to accelerate and it will collide with the kernels. Kernel means the ions present from where the electrons, free electrons comes out. So again it will accelerate, again it will collide, then again it will accelerate, again it will collide. In that way, the electron, this electron will start to move towards the positive terminal. And it happens for each and every free electrons. As a result, the free electron as a whole start to drift towards the positive terminal. This is your drift velocity. Now you see. So in that case, when it will accelerate, say it gains a velocity v1, and that velocity v1 for the first electron, you can write u1 plus, say it accelerates with acceleration a, that is your equation of motion. You can use v equals to u plus at. So v1 equals to u1 plus at1. What is u1? u1 is the thermal velocity already present. Next, for the second electron, thermal velocity u2, then a tau 2. Here tau 1 and tau 2, these are nothing but time. Say this electron collides here, then velocity becomes 0, again it start accelerate, again it collides here. So between these two collision, first collision, second collision, so this is called relaxation time. This is your tau 1. It means between two successive collisions, how much time? It's a very small amount of time, 0.001 second, like that. That time is called your relaxation time. So for the first electron, say relaxation time is tau 1. And by equation of motion, you can write v equals to u plus at. In that case, the t is replaced by tau 1. For the second electron, v2 equals to u plus a tau 2. So for each and every free electrons, we have written the expression of velocities. But we are interested to know the common velocity or the average velocity of all the free electrons. And that is your drift velocity. So that's why you can write, say this is your drift velocity is v1 plus v2 plus so on, vn divided by n. Let us take the average of all these individual velocities of all free electrons. That's your drift velocity. Then v1 is what? u1 plus at1, a tau 1 plus v2 is your u2 plus a tau 2 and so on. Then it is your un plus a tau n whole thing divided by n. Then you see, if you simplify this, Vd, that is drift velocity, we can write u1 plus u2 plus un divided by n plus, and here a tau 1 plus a tau 2 and so on a tau 1. So a common, let me write tau 1, tau 2 plus so on tau n whole thing divided by n. Then Vd is equal to, now you see, it is the average thermal velocity, and already we explained it that average thermal velocity is what? 0. So that's why this value is your 0 plus tau 1, tau 2, tau n. These are your time, relaxation time. Tau 1 is the relaxation time for the first electron. This is the for second electron, and so on. Tau n is the relaxation time for the nth electron. And divided by n, it is nothing but, you can say, average relaxation time. So let us represent it by tau. So that's why it will be your 0 plus a tau. Finally, Vd you obtained as a tau. So finally you have obtained, that is Vd, drift velocity, equal to acceleration into average relaxation time, that is tau. Now just you are to replace the acceleration a, and acceleration a can be calculated by Newton's second law, because as you know, force equals to ma, or you can say acceleration equals to what? Force divided by mass. So in case of this situation, in this case, your electric field is what? E, and we are considering free electrons. So here it is, value of F will be E times E divided by the m, that is mass of an electron. That means if electric field in this room, suppose electric field is E, and if you place a, consider an electron, then electron will experience what amount of force? That is charge into your electric field. That is E into capital E, I am saying here. But if you place q coulomb of charge, in that case, force experienced by q coulomb of charge is what? Q times E, that's known to us. So that's why here 1 implies, finally Vd equals to A is your EE by m into tau, that is your relaxation time. This is the most important expression of drift velocity. So this is your expression of drift velocity. That means all the free electrons, if electric field is E, it moves with a common velocity or average velocity that is given by this expression, and this velocity is known as your drift velocity. Thank you.